You should believe me. We're now broadcasting to the world, Alex.
Hello, world.
Getting set here behind the scenes for recording episode 10 of the Radio Tech Guys podcast, where tonight we're going to talk about audio codecs.
Yes, audio codecs, and hopefully,
It appears that Alex's codec is breaking up.
Just kidding. Just kidding.
So we're about 4 minutes and 15 seconds away from tonight's episode. This is a live behind the scenes video of the recording of our audio podcast. As radio people, we create audio content.
It's live unless you're watching it later.
Right. We're recording these on Sunday nights at 9:30 Eastern for a Tuesday morning release. Except last week on election day when we forgot, and then it was like Tuesday afternoon.
We were a little bit preoccupied.
Just a little bit with the election of a reality TV star as our president. Trump 2016. I'm
going to add that to my email signature, I think.
I don't know why we start these things 5 minutes early. We never.
But we have so much good banter.
I should probably also start a few other recordings before I forget about those as well.
Yes.
So I'll start that one.
So well last week.
Yep, we'll start that one, and I'll start the other one too. Still in the window there, our backup recording solution window.
Yeah.
Mm-hmm. All right, that is also rolling. Oh, that's how I was going to play the theme.
Will that work?
I think so. Should I try it?
I guess.
I'll give it a try.
Here's a sneak preview of our theme song.
This is only a test.
I can hear it.
It sounds like it's working. And if I click it again, listen. It fades.
Oh, man. Hey, quick off-air plug to our friends at Zencastr.
Yeah, really.
What a product.
Yeah.
They've just gone out of beta. Now you have to pay for it, but it's well worth the price.
Yeah, you should check it out.
Zencastr, ZENCASTR.com.
They left a letter out, but
that's how they lowered the price.
Oh boy. Okay, 2 minutes. 2 minutes away. Audio codecs is the topic tonight. Reach us by email, would you? At ask at theradiotechguys.com. We'll be reading a couple messages here coming up, and yours as well if you get it in time. We're going to record 9:30 Eastern time, which is less than 2 minutes away. Quick, Alex, fill time.
I got nothing.
He plays a song on the piano behind you.
Ding 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 ding.
Oh, why don't you just roll it? Why don't you just roll over there?
I shouldn't do that.
Okay. 90 seconds. We have a ton of audio samples tonight too, which I think are going to be cool.
That's exciting.
Yep. Should I sneak peek one of them?
Nope.
I'm going to do it.
Don't do it.
I'm going to sneak peek one. Listen to this amazing audio. Yeah. Think that's a mistake? No, that's exactly what we want you to hear.
I think it sounds fantastic.
We'll tell you why we want you to hear that coming up.
What a tease. That was pretty good.
Thank you. 1 minute. We are 1 minute away.
How do you feel about on-camera lighting?
It depends on what you're using it for.
Just like, a one shot.
I typically do not like it because it's just like this flat. Basically, it's just like the straight on flat light. But in some applications where if it's between that and not being able to shoot it because you don't have any light.
So I'm thinking.
Casey Neistat uses. I just realized what a fanboy I was about to become. And call him by his first name.
CNET.
Wait a minute. You can look up what he uses. For the love of God.
Okay, I'll look that up.
Yeah. All right, are you ready?
I'm ready.
12 seconds. We're gonna go silent here for a minute. It's hard for us, and then we're gonna launch this thing off. Here we go. Welcome to the Radio Tech Guys podcast, episode number 10. It's a podcast all about the technology that drives the radio industry. My name is Chris Moran. I am joined every week by my lovely and talented co-host, Alex Linger.
Okay.
Today located in our home studios, separated by 23.1 nautical miles, probably less than that nautical miles, road miles, less nautical miles. We're talking tonight about audio codecs, how we use them, why we love them, and things of that nature. We'd love to hear from you as well on this podcast, not only on that topic, but anything at all that you might want to talk about, and you can get a hold of us at this very second.
Right now.
Or some other time by sending an email to ask at theradiotechguys.com. And we would love to hear from you. What, Alex?
No, you're fine.
Okay.
I was not responding to you.
That's good. You can reach us by email at ask at theradiotechguys.com. We'd love to hear from you now, or any other way that you want to do that. Social media, perhaps. Lots of options there, right?
Yes, there's the face page and the Tweeter.
Yep, at Radio Tech Guys on Twitter, or just search the Radio Tech Guys on Facebook. We can hear from you there. Of course, subscribe to this audio podcast. You can do that on iTunes, the Google Play Store, or on Stitcher, which is available there now as well. What is going on?
You know why I like Stitcher?
Why?
You know why? Because when you press, if you've been listening to something and you press play, you get this nice British lady saying, "Resuming episode."
That's pretty cool. I've heard that.
Yeah, I love it. That's
pretty sweet. What's going on?
Not much. Fairly well. I was about to say it's been a fairly standard week. However, given the events of Tuesday, November 8th. Was it the 8th?
Yeah.
It's Tuesday. I don't know. It's been a week. It's been a crazy week for media outlets across the world, and you know why. We had an election, and it was a pretty wild election. And we, of course, got wrapped up in that as well, given that we are part of the media world.
Yep. Yes, it's been wild for sure. We survived. We had some cleanup to do actually in our office / command center. It hasn't recovered from Tuesday, but we're going to get into that this week.
What's up with you?
Yeah, about the same. Trying to recover still. Been that Tuesday was a long day.
The long day and night.
Hey, I want to do something real quick before we jump into the topic today, which is audio codecs, different algorithms that we use to compress audio for various ways here. I wanted to take just a minute to read an email that came into us this week at ask@theradiotechguys.com.
Somebody emailed us?
Yeah, they did. Not the first one.
That's amazing.
Yeah,
I know.
This one I thought was helpful, partially because this is the same guy who also suggested the topic for tonight. Philip wrote into us, but I thought some of these questions about a couple of things we mentioned in our previous episode might be helpful for other people too.
Indeed.
I'm just going to read part of this email. He was talking about the podcast that we did on HDFM, secondary channels and HDFM, and he said, I wanted to ask if you've noticed any self-interference when expanding your HD bandwidth, the additional 24K. And he's talking about, we mentioned that we had enabled the extended sidebands on one of our HD carriers in one of our markets to get more bandwidth available there. And we had talked about self-interference some in other ways. But when I responded to him, the short answer is, I guess, yes and no. It's not really a short answer. It's the problem we've run into is that we are running a tube type transmitter, and this is a station with a 20 kilowatt TPO. We have a tube final, and we're also licensed for minus 10 dB insertion on our HD carriers. And so what we're finding here is that's a disastrous combination of that much energy in the sidebands when you extend the sidebands on in a tube final, where the tube just from the day you turn it on gets less, its performance becomes less linear from the moment it starts to run. And so in that regard, we have opted to reduce our HD injection to minus 14 to help kind of offset that and minimize our self-interference. But yes, there is definitely a difference in self-interference with those extended sidebands turned on. I thought that was worth pointing out from his question, and yeah, that was good to
Yep.
hear from him. So yeah, that's that.
Thanks for your emails.
Seriously,
Appreciate it.
keep those coming. All right. Audio codecs, Alex. This is another one of these big topics, but I think we can just kind of scratch the surface maybe and boil this down. Help me think. There's a lot of applications where in a radio plant and
Oh
throughout
my
a radio
goodness.
operation, the audio codecs is used. And that's part of the problem, honestly, when they end up getting stacked behind each other.
Exactly. Yep.
There's also some places where it's very bad to have codecs where we don't ever want codecs to be used in a world that we can control.
Yep.
Here's where you shouldn't ever opinion should never be used. Automation systems for your audio playback of your stations, especially for music libraries, should never, ever, ever be coded audio like MP3s and the like, but it happens all the time.
Linear, clean.
It happens all the time, even in our company, where our policies are that we don't use them. The reason that's a major problem is not, I mean, they could be a really high quality MP3, but if you've got any additional encoding algorithms down the line from there, and that's the start of the playback, and you start stacking these codecs on top of each other throughout your playback system and on into your transmission system, you're just asking for all kind of trouble.
Funny story. Can I tell a funny
story?
Yeah. We worked with somebody. God bless him. We had access to high quality music downloads, like licensed, we're a radio station. So we had access to this music. He still chose to torrent the songs.
Why would you do that? Why?
Not illegal, but crappy audio.
Yeah, bad life choice. So there's an example of a place you don't want it. Anymore, you don't want to do it if you can get away from it, even in your STLs. That's a major source of using coded audio that's been there for a long time. And then there are some places where you can't help but use it. Things like your web streams are obviously undoubtedly going to be encoded. Live remote IP broadcast equipment, even ISDN broadcast equipment, is going to be using some form of algorithms to encode. So,
and that's a necessary evil. That's a bandwidth thing. You've got to get it through a small pipe.
Right. Lots of data, small pipe. That's the need for encoding. So that's what we wanted to kind of jump into today. We have a handful of things we're going to play for you as we get going here too, but we wanted to just real quickly go over some of the most popular audio codecs that are in use today. And certainly there's a handful of them that are used universally in just about all the applications that we mentioned already. There's AAC, which is an extremely popular, highly efficient, high quality algorithm that we have utilized in ISDN broadcast equipment for remote equipment that we have, web streams of various kinds. That's a very, very popular option. IP audio codecs that we're using, like the Telos Zip 1 and others, are AAC heavy. Then there's the older MPEG family, MPEG 2 and MPEG 3, also readily available in your ISDN units. A lot of your other stuff, not as common anymore, I don't think, in the web streaming industry, although some carriers and platforms still, I think, use MPEG encoding for their streams. There's also other variations of the AAC family that we mentioned beyond just AAC standard. There's low delay, AAC LD and ELD. There's AAC HE series. And then we get back in time into the ancient days of G.722, G.711, ULaw, and some of the other.
Those are my personal favorite.
What? For what? Just in general?
I'm just kidding.
Yeah, those are beautiful.
They're terrible.
They're not great for anything to sound up to par today. So we wanted to kind of talk, and then within each of those families, we should point out, except the G.dots, the MPEG families and the AAC families are all, there's a range of different bit rates that you can use, or how much data that you're pushing through on these codecs. And the whole point of this, what happens with these codecs is that they, whether it's a hardware appliance or a software encoder, is taking linear, uncompressed, good audio in, and then stripping out a bunch of bits, bunch of ones and zeros are getting removed, and by all these algorithms, it's taking them out, making the file size or the throughput size much smaller. And then at the other end of that, there's either software or hardware that is decoding that newly compressed stream and regenerating those missing bits that were stripped at the other end based on whatever kind of algorithm knowledge that it has to recreate them. A lot of these do a really good job of doing that quickly with low latency, very efficiently, and with very good quality, considering we're talking about reductions in size that are very significant. Like I'm looking at a 128 kilobit per second AAC file here that is 1/11th of the size of the original WAV file that I encoded these from.
Wow.
So, I mean, we're talking about significant reduction in file size and throughput requirements for minimal audio quality trade-off, right?
Yep. That's interesting.
So here are, I don't know how to best formulate this. We're going to play a bunch of audio here. I have a song that I want to mention. This song is called "Wanna Be Yours." It's by the Tide Rose, and we licensed this song through soundstripe.com for use in this podcast, so it's completely legal to be included here. But the way I've set this up is I have this song, I have its original form. It's going to be very hard to tell because you got to think the podcast, if you're watching this on our Google YouTube channel, the audio on here is extremely heavily encoded with a lot of artifacts. This will not be, I guess we should probably post these files. We'll put links in the description of this actual podcast release on our website when it releases on Tuesday to download these files, because you're not going to be able to accurately discern this from the YouTube channel, much more accurately discerned from our actual podcast audio episode. It's a 192 kilobit per second MP3. But anyway, if you want to really dig into these and hear them accurately, we'll put links in there where you can download these files. So what we have is this song is a linear wave file as we downloaded it from the licensing house. And then we've encoded this a number of different ways, a bunch of different flavors of AAC and MPEG, G.7, and a couple other things. And then I have this other really cool thing, which we'll get into after we listen through some of these samples, about how we can really drill in and listen to the artifacts that are being generated by each of these codecs. So what do you say? Let's jump in here and listen to a couple of these samples. We'll start with the let's start with the MP3, the MPEG layer 3 family, and we'll start with highest quality to lowest. But first, this is the original source file. This is the original linear wave file as downloaded from the artist.
It's you on the telephone. I'll let the voicemail take, if only just to make it seem like I'm not alone.
I selected this song because of acoustic guitar and female vocal being specifically difficult for these algorithms to encode properly. And that's what I want you to listen to particularly, is her vocal and some of the acoustics. We'll skip ahead a little bit as we get through some of these, so we don't have to listen 35 seconds to get into the end of the vocal. So that's the original wave. Let's listen now.
The song also has a nice sonic range. You've got low end bass, and the high end, and the voice and the guitar. I think that's a good. There's lots of separation there.
Yeah, good range. Yep.
Let's hear that.
Let's start with the 320 kilobit per second MP3. I'm going to bet for about 99.8% of you there is absolutely zero indication that this is not the original linear file. And and we'll skip ahead.
Another night it seems. I know that when it rings, it's you on the telephone.
The high end is still
I'll
retained.
let the voicemail take, if only just to make it seem like I'm not alone.
Sounds really good.
Yeah, when we get further down these bandwidth ones, we'll go back and forth in between while they're playing. You'll be able to hear more. Let's jump down. I had another one here. We'll skip it. Let's jump down to a fairly standard 128 kilobit per second MP3 and listen to that for a second. And we'll skip ahead.
Another night it seems. I know that when it rings, it's you on the telephone. I'll let the voicemail take, if only just to make it seem like I'm not alone.
I'm going to go back to the original.
Only just to make it seem like I'm not alone. I know when you call me. I know
And the
when you
MP3.
call me. I wish you would call. I wish you would call me something more. Call me
MP3.
something more. I wanna be yours.
To the casual listener, you'd never notice a difference, I don't think.
We're at an extreme disadvantage. Yeah, I know we're listening to, so I think I hear things.
Yeah, exactly. Yeah.
I hear it on the S's, I think, on the top, very top end of
Yes.
that stuff. So now we're going to get crazy. This is where you're going to really start to be like, what is this that I'm listening to? This is a 64 kilobit per second stereo MP3 of this same song. Now, clearly, there's a significant amount of coding artifacts that you're going to hear in this. You can already hear the swimmy and the lack of resolution at the high frequencies. Let's skip ahead.
I know that when it rings, it's you on the telephone.
We'll go to the wave.
I'll let the voicemail take, if only just to make it seem like I'm not alone.
And the 64 MP3.
They'll take, if only just to make it seem.
Okay, obviously. We won't go any
Yikes.
further. We had a 32 kilobit MP3 right here.
Seem like I'm not alone.
AM radio.
Yeah, not any good. That's the MP3 family. Here's my favorite thing. I've done this in a lot of different, this kind of experiment and example when I've had to prove performance on a number of things. And we really did a lot of this when we were first deploying Arbitron PPM encoders, because they also have, there are some audio related things with that we were listening for. So what I've done in this instance is I've taken the original wave file in a nonlinear editor, a multi-track session, and I have reversed its phase. And then I have identically time aligned these encoded files on other tracks below them and unmuted them, and they're time aligned perfectly, so they're phase canceling. And so what we're hearing in these audio files here is just the differences between the original linear wave file and the encoded file. It's going to sound very interesting to you, and as we go down the list, you'll hear more and more artifacts. We're going to start with higher bandwidth, higher bitrate encoded MP3s to lower, and we'll start with 320 kilobit per second MP3. What we're hearing here is just the differences between the encoded MP3 file and the original wave file. I'm not adjusting gain or anything on my console in this part of the podcast. These are just going to be remaining artifacts between the two. Bizarre, isn't it? I know it's
That's wild.
It's not the most compelling thing to listen to, but these are So if you've ever questioned what the swimminess is that you're hearing in these MP3s, this is the highest. I mean, this is a 320K MP3, and these are the artifacts that exist. Let's go ahead and jump down to a 192 kilobit per second MP3.
I mean, it's just garbage.
So that's 192 kilobit per second MP3 artifacts. How about the most common 128 kilobit per second MP3? Here's what it's doing to your music when you insist on using it instead of WAV files. Listen to this. That is all noise that does not exist in your original file. Want to get crazy? 64K MP3. This is where you start to say, and finally, like you would ever do this, a 32K MP3. Hear all the top end that you can hear now? That's stuff that's not even making it the top of the shaker, her S's.
Wow.
We can do the same experiment with AAC. We'll do it a little bit differently. I'll click down through here through each of the bit rates of the files, and I'll do the same thing with the encoding. It's very similar. The artifacts are similar but different between MP3 and AAC. Here's the actual songs first, is in the AAC encodings. This is we'll start with the wave again, and then we'll jump right into the AACs. Here's the original wave. We'll skip ahead to some actual content.
Something more. I wanna be yours. I wanna be yours.
And here comes a 320 AAC.
And by the way it rings, I know what I'm offering is not enough. You answer quietly, as if accidentally I called.
192.
I called your love. I know when I call you, I wish I could call you something more. I wanna be yours.
128.
I wanna be yours.
I wanna be yours.
I definitely think AAC wins at 128. Here's 64. I think it smokes MP3 at 64. Here's 64 on AAC. Here's 64 on MP3. AAC, 64. I mean, smokes it. I don't know that we need to run down the entire list of artifacts for AAC. They're very similar. We'll make sure all the files are available. But it's really shocking to me every time I do one of those phase canceled comparisons, just how we've become okay with, for the sake of storage capacity or whatever, even on our phones and whatever else, just
Junk
with compressed, artifacted audio like that. It's a little bit shocking, really.
It's funny too. This is a rabbit trail, bunny hole. Bunny trail. That's what I was going for there. Anyway, it's funny because you mentioned storage, and storage is getting bigger and bigger and cheaper, and yet our audio files are getting worse and worse and worse.
Yeah,
it doesn't make much sense. But yeah, it's crazy when you really break it apart and hear just the absolute garbage.
I was really surprised. I don't know that I had done this with just straight out MP3s.
Yeah.
In a lot of cases, I had done this before for like audio processing. Actually, we wanted to hear in proof mode of a couple audio processors, and then also what those freaking PPMs are doing.
And they're doing a lot.
They're doing a lot. Yeah, we we've heard some of that, the watermarking and that kind of stuff. But I don't know that I've ever done one. I was pretty surprised, honestly, even at the highest quality. Here, we'll just do one. This is the highest quality AAC artifacts that remained after I did a 320 kilobit per second MP3 comparison or AAC comparison. But listen, barely.
Yep.
Even it's that's 320 AAC compared to 320 MP3.
Wow.
AAC is just, it's a much more accurate codec. And I'll tell you, also to make this test a little bit more manageable, I should disclose that I summed all of these to mono before I did the comparison. So each of the, I mean, it's a mono. We're not even listening to the artifacts that exist in a stereo file. I did that. I didn't save any of them, but I did that separately. And just the inaccuracies and how it handles the left minus right information between the two, it just adds a whole other level of inaccuracies that exist.
Yeah.
Take away from that what you will, other than to say that AAC beats MP3. Definitely in music. All flavors of AAC are superior. There's some cases where you can't use AAC. That's not available in all devices or applications, but it's definitely a superior codec. The real takeaway, though, is not to use encoding when you don't have to. Use linear audio in your automation system and whatnot.
Yeah. I'm reading a very interesting article here on techradar.com. Maybe we'll put this up on our site with this episode, but it talks about how MP3 compression works, what it's actually doing to the audio. It's very interesting. It's sad, all my years in doing audio things, I've never looked this up. I've never really researched it, but it's in some ways, I guess you could say it's similar to the same principles of MPEG video compression, where basically anything that doesn't move for video, anything that doesn't move doesn't get rewritten in the next frame.
I see.
But of course, it's very different for audio, but it's kind of the same principle. It relies on masking certain frequencies. It basically literally using psychoacoustic principles to make you think you're hearing frequencies that aren't there, and vice versa.
I see. So that's
we'll put this article up. It's very interesting.
Yeah, it's fascinating. I've looked a lot more at video compression over the years than audio. And if you've ever been watching, well, really anywhere that you watch things online, any of the very famous common streaming services or YouTube or Vimeo videos.
Yeah.
And if you've ever noticed when when you're at a really slow moving scene or a close up of a person that's not moving much and things look great, but as soon as something changes, you start to see blocks, and sometimes there's even like shadow figures of people where they were a minute ago. That's exactly what Alex is talking about, and that it's adapting its compression. It's not rewriting the frame, every pixel in every frame exactly as it sees it. It's analyzing it that quickly. I mean, virtually in real time. There's a little latency, but very quickly analyzing frame to frame and saying if it's not different or dramatically different, let's not rewrite it. Let's just slightly modify it or use the same thing. And then suddenly it switches to a frame where this person's not here anymore, and then there's a ghost of them left on the screen. It's a compression error.
Yep. That's
pretty fascinating.
Very, very similar for MP3, but also very different. I probably shouldn't say very similar, but it is when you think about it. It's kind of the same property, but very interesting. And I don't know anything about AAC. I should look that up.
Yeah.
Too.
So those are the codecs. There's another kind of it's not exactly talking about a codec, but it is talking about multiple bit rates. And we're talking about things like adaptive streaming, which a lot of you are using and may not even realize it, both in your transmission not like on air transmission, but like of web streams and video streams and whatnot. But you're definitely taking advantage of it when you watch things online or you watch things on your Apple TVs at home or whatever. And that that is just adaptive streaming is just when, as the publisher, you create multiple bitrate streams of the same content for different audiences devices to automatically adaptively select which stream is most appropriate for them based on their current bandwidth conditions. For instance, you may put up a very high bit rate 300 kilobit per second stream, audio stream, but at the same time that you're sending that one to the server, you're also sending a 128K stream, and you're also sending a 64K stream. So take the sum of all those, do your math. 500, so it's almost 600 kilobits per second that you're pushing to the server. But then the server's determining or the clients, when they connect to the server, are saying, well, gee, I have really bad bandwidth here. I only have 80 kilobits per second available really to commit to this stream. I'm going to play back the lower quality one for the sake of not as much buffering or interruption. You almost have to do that when you get into the video side of things, where we're talking about, when we push a 720p broadcast out of our production truck when we do sporting events that's greater than 4 megs per second. We know that not everybody is going to be in a position to watch a broadcast of that much bandwidth. And so we have a service that we use for video called Wowza that is doing the transcoding for us, where we're pushing them a single stream and then they're providing us different streams of different bandwidth and different formats available depending on the client player. And that's adaptive streaming. It doesn't really directly relate to the codecs or the audio coding that we're using, but more the service that we're using to stream that to our audience.
And not everything does adaptive streaming because it's very processor intensive. It's doing a lot of work to serve multiple streams. I mean, one stream is hard enough, but when you're transcoding is really the key. That's what it's doing, a lot of work to do that, and then provide individualized streams based on bandwidth. That's difficult. So that's normally only found in the high end, more expensive stuff.
Yep, absolutely. I was looking, actually, we mentioned this on a previous episode. There are a handful of devices that are hardware appliances that are available for streaming. In our company, for our radio station's web streams, we use all software appliances, all software interfaces for our streaming. There are hardware appliances out there made by a handful of people that are kind of cool. Telos is one. They have some software that we use for processing for the streams, but I've never really looked at their hardware boxes. I think some of them are pretty new.
Very new.
But
they look cool.
There are obviously advantages to hardware being dedicated. We have more trouble, it seems like, keeping these streamers running. We keep replacing 10-year-old computers constantly. It might be something to look into, a hardware solution. What you think?
I think that'd be wonderful. Power supplies like to fail a lot. So do hard drives.
Yep.
Also, not to change this. Well, it's the same topic. I'm reading about AAC. It's fascinating because it's doing some crazy stuff. Crazy stuff. And I guess that explains why you have to license it.
Yes.
Because it's a crazy algorithm. In fact, high efficiency AAC, mainly version 2, apparently. It's kind of the same, but version 2 does it a little differently. So if you have a stereo source, a stereo input, this is cool. So it's creating a mono signal and then creating like a file, if you will, of information to send with it. And then the decoder takes that mono signal, reads the information, and splits it back out into stereo.
Yeah, that's very much how FM works. It does exactly the same thing. So FM is transmitting one mono main carrier, and then in their subcarrier there's left minus right information that tells the decoder how to how to. It basically tells us what the difference is in the two channels, and that creates the stereo from there. That is
Very cool stuff.
fascinating. Yeah, AAC is it's newer, right? It's newer than
Yes.
MP3.
Yes.
Initially released in 1997.
That's correct.
Huh.
Yep. It was first specified in the MPEG 2 Part 7 standard.
I don't know, Alex. Perhaps we should have read these articles before tonight.
No, that's silly. Let's do it on the air while we're doing the show, Chris.
Well, that's
we're
good
learning
stuff.
with the audience, okay?
Exactly. So we want to we're going to post all of these files. We'll just put them in a shared Dropbox folder. All of these sample audio files and the encoding algorithms, as well as links to read more about AAC and MP3. What other housekeeping things we need to do this episode before we close it up?
Well, let's just remind everybody how they can get a hold of us and talk to us through the week.
Oh, I know what I needed to ask you.
What?
How's the Pathfinder video that you promised us last week coming, Alex?
I was hoping that wouldn't come up. I did not forget. I want to make that very, very clear. I did not. Oh, did you see what I just did?
Oh, the Donald is alive.
I have the hand gesture. Okay. I did not forget. I kind of pushed it off for two reasons. One, this week got insane with the election. But two, I'm going to have some gear to better create these videos soon.
Yeah.
So want to make a good video for you. So next week. So I say.
All right. Well, we'll believe when we see it on the YouTube channel.
Yeah, no joke.
Sorry, you were going to tell us about getting a hold of us, and then we can
Oh,
close
yeah.
this thing up.
Yeah. So don't forget, you can get a hold of us by email at ask at theradiotechguys.com. As always, visit our website, theradiotechguys.com. And on Twitter and Facebook, Twitter at Radio Tech Guys, and on Facebook at Facebook is facebook.com/the-radio-tech-guys. I just read our script verbatim.
Well, it didn't work
Whoops.
out. Shouldn't do that. Don't ever trust the script.
Teleprompter fail.
Beer and wine review should be quick for me anyway. I'll let you go first.
Mine's quick too. Boy, I'm sorry, folks. I'm repeating one, so I don't have much of a review for you. I'm drinking from Flying Dog, the Bloodline, which is the scary, creepy, bloodied up dog.
I remember him.
Yeah.
Just refer back to episode 7 or whatever that was for.
Exactly. It's exactly the same as it was before.
You feel the same about it. Your mind hasn't changed. Mine is also very quick. This is Screw Top, which we've determined is not necessarily a problem.
Not a problem.
But this is Riuniti Lambrusco. This is light and refreshing with bright flavors of juicy berries and a dark cherry. Oh, no, not a dark cherry, but just dark cherry. It's soft with a lively finish. I have described it as basically fruit punch that has like soured a little. That's
gross.
Pretty much how what I've deemed it. It's fine. I don't know how much it costs. It's probably $3 and at Walmart, and it's not there's anything wrong with Walmart.
Well, never mind. Chris and I were talking about this wine before we started, and I said, "Do you remember like when you went to 8th grade dances and somebody like spiked the punch?" I think that's what he's drinking.
That's pretty much it. Pretty much it. All right, good times. Don't know what next week holds, but it'll be there.
We'll wing it.
All right, that's it. Thanks very much for hanging out with us. We'll talk to you next week.
Bye, everybody.